Hi, my name is Sabine. I am part of Mathnasium's social media team, and this is Larry Martinek, the Chief Instructional Officer and co-founder of Mathnasium. Today, we're going to be talking about number sense. Larry, can you please explain to us what number sense is?
Well, I once asked a group of teachers, what is number sense? And the chairman of the math department raised her hand and said, "Is that which all children do not have?" Very interesting answer. And I found that fascinating because it kind of showed that there's not a great consensus out in the math community as to what exactly number sense is. Some people see it as like addition, subtraction, multiplication, division, number sense. It's just another item in the list of things that kids learn.
Right.
From the Mathnasium perspective, however, it's a much broader notion. This chart that you see here, there's a triangle showing in the center of the triangle is the phrase number sense.
Right.
And over the course of the 37 years I've been teaching, I've put together a construct of what I perceive number sense to be. And the three principal elements are counting, wholes and parts, and proportional thinking. Now, each one of those is a very compact idea. When people hear the word counting, they think of like babies counting in a crib, counting 1, 2, 3. But counting is also a very sophisticated process that's used when you do probability, even when you do calculus. There's counting involved in everything. So one of the underlying ideas of number sense is being able to count. One of the phrases we use at Mathnasium is we want students to be able to count from any number, to any number, by any number, forward and backward.
Okay.
So we have exercises, for instance, kids do things like count by fives, 5, 10, 15, 20. But also, let's count by 10 starting at 17. So 17, 27, 37. And when I said from any number, to any number, by any number, let's count from 0 to 7 by 1 3/4. A little bit more of a challenging exercise.
Right.
So counting is not just a mundane, restricted to just whole numbers. It can be multifaceted. The next item in number sense is the notion of wholes and parts.
Okay.
One of the great crises in math education right now is that kids get out of elementary school into middle school and even into college prep algebra, and they don't understand fractions.
Right.
And one aspect of wholes and parts is indeed understanding everything there is to know about fractions. But also wholes and parts have other meanings as well. And when you have an equation, 7 plus 3 equals 10. Well, the parts are 7 and 3, and the whole is 10. Because I'm sure everyone has heard that expression, the whole is equal to the sum of its parts. Right. Well, in this case, 7 plus 3, the parts are equal to the whole, which is 10. At Mathnasium, we take that one step further. And in addition to saying the whole is equal to the sum of its parts, each part is equal to the whole minus the other part. So if you think about it, 7 is equal to 10, which is the whole, minus 3. Right. So the wholes and parts could be fractions, but it also is any relationship that involves the wholes and parts, and especially in combination like I've been describing. Euclid, in fact, was who we credit with Euclidean geometry, was the first to historically make the statement the whole is equal to the sum of its parts, and it's been a guiding principle in mathematics for pretty much since the dawn of mankind. Right. And I've incorporated that into our material at many levels, starting with kids as early as kindergarten, of teaching them how to figure out half of numbers as a beginning, and going all the way then through fractions, through equations, and all the myriad forms that wholes and parts take. Okay. The third element that we consider crucial and to say that a student really has number sense is what's known as proportional thinking. There's kind of a classic question that says, a 6-foot man casts an 8-foot shadow, so how tall is a tree that casts a 20-foot shadow? Now, a lot of kids answer that question 18, because the man and the tree there's a 2-foot difference. But the answer turns out to be 15, because the relationship there is not a matter just of how far apart they are, but what is the relationship between the numbers. And it turns out the shadow of the tree is 2.5 times the shadow of the man. So the tree has to be 2.5 times the shadow. The height of the tree has to be 2.5 times the height of the man. Right. And that's a proportional relationship. And far too many kids get into middle school and into high school only thinking about distances, how far things are apart, and never how many times bigger or how many times smaller one number is than another. And this is the blood and guts of what number sense is about, is being able to make these kind of distinctions. And this is a process that takes, not something that's done overnight, and it takes many years of learning a whole host of ideas that finally come together to be able to think naturally this way and determine, gee, do I want to know how far apart numbers are? Do I want to know how many times bigger numbers are? This is what number sense is really all about.
Okay.
Some slightly more mundane aspect of it would be to just, when you get an answer to a question, is to judge, is that answer reasonable? Like a question like, what is 7% of 300? Which in the Mathnasium way of thinking about it would be to count 7 for the first 100, 7 for the second 100, 7 for the third 100. The answer is 21.
Okay.
But some kids get 210 because they take,
Wow.
well, they take a calculator and instead of putting in .07, they put in .7.
Okay.
So the answer is 10 times too big.
Right.
But they write down 210 as the answer and have no idea that it's wrong because they don't have a sense.
To realize that 7% of 300 could not be that big, right?
That's way over half.
Exactly.
So number sense is, again, well, like all the elements in their number sense triangle, is multifaceted. And so we use it to estimate answers before we start, to determine whether the answers we get are even in the ballpark,
Right.
as that example I just said. And when these three elements come together, an interesting thing happens. We have three triangles here that I draw, the counting, the wholes and parts, and proportional thinking.
Right.
When you bring them together, they actually form four triangles, which is the number sense in the center. So in one sense here, the whole is greater than the sum of its parts. When these three parts work effectively together, we get this wonderful magic creature called number sense.
Okay. Thank you very much, Larry. Thank you.